Welcome everyone. Welcome to this video tutorial on the topic of zero crossing detector, what we call it as ZCD. The immediate application of comparator is zero crossing detector. It is also called as a sine wave to square wave converter. The various types of zero crossing detectors are: the first one is non-inverting zero crossing detector, inverting zero crossing detector, and capacitor coupled crossing detector. So we will see all the three in a more detailed form. The first one, the non-inverting zero crossing detector. In a non-inverting zero crossing detector, the op-amp is used in open loop configuration. The inverting terminal of the op-amp is grounded and the input is applied to the non-inverting terminal. Now the operation of the circuit: when a sinusoidal input is applied during the positive half cycle of the input voltage, that is above the reference voltage, input is above the reference voltage, the output voltage is nothing but it is plus saturation, plus Vsat, and during the negative half cycle of the input voltage, the output will be minus Vsat. Thus the output voltage switches between plus Vsat and minus Vsat whenever the input signal crosses the zero level. So this is about the non-inverting zero crossing detector. Next, moving on will be inverting zero crossing detector. In the inverting zero crossing detector, the input is applied to the inverting terminal and the reference terminal, that is non-inverting terminal, is grounded. Again, the op-amp will be used in open loop configuration. So the circuit operation is as follows. So during the positive half cycle of the input voltage, that is when Vin is greater than reference voltage, the output voltage will be minus Vsat, and when Vin is less than reference voltage, the output voltage will be plus Vsat. Thus for negative half cycle the output is plus Vsat, and for positive half cycle the output voltage is minus Vsat. So here we call this circuit also as an inverter circuit. The third type of the zero crossing detector is a capacitor coupled crossing detector. Here we don't call it as a capacitor zero crossing detector, capacitor coupled crossing detector. So in this case now, the non-inverting terminal of the op amp is connected to ground through R1, and input Vin is connected using the coupling capacitor C1 to the non-inverting input. The resistance R1 is required to provide the path for the DC biasing current. The inverting input terminal is biased to plus VB, that is a level slightly above the ground level, using the potential divider R2 and R3. This ensures that if no input is applied, then op amp sets its value to negative saturation, that is minus Vsat, due to the inverted action. When Vin drives the non-inverting terminal above the level VB, then the output switches from plus Vsat to minus Vsat to plus Vsat. Now, when VA falls below VB, the output switches from plus Vsat to minus Vsat. The resistance R1 is designed such that R1 is equal to R max, which is equal to 0.1 times VBE divided by IB max, where IB max is the input current of the op amp. For the sinusoidal inputs, to eliminate the phase shift error which may make a circuit unstable, Xc1 must be smaller than R1 at a minimum signal frequency. That is, we are using the condition here: Xc1 is equal to R1 divided by 20, and here C1 is nothing but it is 1 divided by 2 pi FL times R1 divided by 20, what we are using. it is assumed that input impedance of op amp is very large compared to that of R1. With this assumption, we are deriving this particular relations. The another type of a detector, what we call it as a voltage level detector. So in this circuit now, one of the op amp input terminals is biased to the input voltage which is to be detected. The non-inverting terminal is biased to V level, what we call V level voltage, which is the drop across the resistance R2 and can be set to a level to be detected. As basically it is inverting configuration, when V in increases above V level, the output changes from plus Vsat to minus Vsat, and when V in decreases goes below V level, the output changes from minus Vsat to plus Vsat. Thus the required voltage level can be detected. Biasing the non-inverting terminal to minus V level, the negative voltage level detection is also possible using the same